Hey, relative motion. That's what we're going to do right now. A pet store supply truck, just an example, moves 25 meters per second north along a highway. Okay, let's draw that. Drawing's cool. All right, so we got a supply truck. I'm going to make my supply truck gigantic and gold. Okay, so here's the top view of the back part, I guess, of my supply truck. And it is going down the highway. Whoops, I don't want that. It is going down the highway at a speed of 25 meters per second. So it's going, we'll call that north, down a highway. And inside we have a dog, which we'll use just a little blobby circle thingy to represent the dog. And I'm going to extend this line on down through here. Okay, so imagine you're in a helicopter and you're looking down through a supply truck with a glass roof, and you can see this dog going around. Now, outside the truck, there's a guy out here, okay, watching all this happen. And the dog, it says inside, a dog moves 1.5 meters per second at an angle of 35 degrees east of north. Okay, so let's draw that. So here is, let's make this like a little XY axis, and we'll call this east, and this, of course, north. And this dog is going 1.75 meters per second, 35 degrees east of north. So that's to the east from the north. So it's kind of like this right here. Okay, so we got a dog moving in here like this, 1.75 meters per second. And this is a 35-degree angle. Okay? All right. We want to know, what is the velocity of the dog relative to this guy outside of the truck on the side of the road? Well, what we need to know is how far, or not really how far, but we want to know the speed vectors of the dog and the truck. Okay, because the dog is moving with the truck. So to this guy out here, to this blue guy here, the dog is moving faster than 25 meters per second. So I think what we should do is find and look at this triangle right here as a right triangle and find, maybe we can call this Y and this X. In fact, let's just call that Y and X right there. And these little, this blue line and this yellow dotted line right here, from here down. So if we do Y, that would be cosine of 35 equals Y over 1.75, and we would multiply that. Okay, when you do that, you get 1.43. So Y would equal 1.43. And let's label this, and no matter how big I draw this truck, the data inside gets small, and then you almost can't see it. So this is 1.43. Now, this little component vector here moving toward the guy. See, this is moving directly in the direction of the guy outside the truck. So we need to find x2, and that's going to be the sine of 35 equals x over 1.75. And we'll just knock this out real quick. 1.75 times sine 35 equals. And that is 1.0037. I think we can call that 1. So let's put little squigglies showing we're rounding, and we can call that 1 meter per second. And we can label these both meters per second. Labeling this, that would equal 1 meter per second. All right, now I'm going to make a red triangle that is in relation to the dog and the truck speed in relation to the guy outside the truck. So if this is my northern component vector, my north vector, how big is that? How fast is that? Well, it's going to be 25 plus 1.43. So that's 26.43 meters per second. And then the dog happens to move this way just a little bit. I mean, just barely. If we're drawing this to scale, I probably already drawn that too long. But I will exaggerate it a little bit to give it so we can see what's happening. And then we have to find the resultant vector, which is that yellow line right there. That. But this dog going this way is 1 meter per second. Okay? 1 meter per second. Uno. 1 meter per second. So what we need to find is not only the length of that yellow velocity vector, but this angle in here as well. And the angle is very, very small. So it would be, let's see, to find the length of the line, we would do Pythagorean theorem on it. And we would have 26.43 squared plus 1 squared equals c squared. I'm going to pause that and figure that out. So this is the square. So c squared equals, after you do that, 697.96. So I'll just call that. How about we just call that 698? And then we square root this. Just hitting the buttons, which is about 26.5-ish. About 26.5. And it's just barely longer than this side here, 26.5 meters per second. So that's our resultant vector. And now to get this angle right here, we would need to do something like tangent of angle theta, if we call that angle theta right there, equals 1 over 26.43. Well, to do that, that's second tangent, and then 1 divided by 26.43, which is about 2.17. So theta is about 2.2 degrees or 2.17 degrees. And that would be also east of north. East of north. So our final answer is 26.5 meters per second at a 2.17 degree angle east of north. Have a good Friday.